Hello everyone, welcome to the chemistry class. My name is Lorika Raj, chemistry faculty. So we'll be discussing a very important topic, that is mole concept. And this concept you have to apply in all the three specializations, whether it is physical, obviously it is the base of physical chemistry, but this concept you have to apply in case of organic also, in case of inorganic chemistry also, because whenever there will be any some sort of reactions where you have to see the stoichiometry, you must be aware of this topic. So today we'll discuss about this topic and then we'll solve a numerical, right? So what exactly is mole concept? I should rather say it as it's a unit of counting particles, especially for chemists, right? So just a minute. So let me choose the okay, this. So what exactly is mole? Mole is, you can say, a unit of counting particles, especially for chemists, right? Unit of counting particles, especially for chemists. So whenever there will be a mole concept, you must be aware of the you can say the unit, right? Unit is unit, or you can say a number, especially a number, that is Avogadro number. What exactly is Avogadro number? Avogadro number, and it is equal to 6.022 or sometimes 023, right, into 10 raised to power 23 number of particles. And why I have written here number of particles? Because it may be an atom or it may be a molecule. So it completely depends whether you are taking a question of atom or a molecule. So now I'll describe this mole concept in, you can say, three kinds of definition, right? So basically, firstly, what exactly is mole? I hope you got it. First definition, or you can say first relation for this mole concept is that 1 mole is, just a minute, 1 mole is equal to, if you want to correlate this mole concept, you can correlate with it with the mass, with number of particles, and the third one is especially for the cases of only gases, right? So in first scenario, I am now connecting this 1 mole with masses. So 1 mole is equal to atomic mass when, if the particle is an atom, if the particle is an atom, right, is an atom, but it may be molecule. So atomic mass or molecular mass, molecular mass, if the particle is a molecule, right? So next is it clear? If the particle is atom or it is molecule, right? So let me change the slide. Can I take an example? Yeah, sure. Why not? Without example, we'll not be able to get it. What exactly is 1 mole? 1 mole will be equal to, if I am taking oxygen atom, you know that atomic mass of oxygen is atomic number, you can say. Atomic number of oxygen is 8, right? BCNOF. So it comes after nitrogen. Atomic number is 8, but atomic mass is 16 gram of, you can say, oxygen. But if I am taking it as molecule, I'll be writing it as 2 into 16, right? Because if I'm taking as O as atom and O2 as molecule, right? That's it. 2 into 16, that is 32 gram of O2. So this was the first definition. Now here comes the second definition. What exactly is second definition? If you want to correlate this 1 mole with the number of particles, then you have to apply this second definition. 1 mole again will be equal to what? If I am saying that you have to correlate this mole with number of particles, again here comes that the same number, Avogadro number. So should I write it as Na? Na, that is, you can say, representation of Avogadro number, or I can write it directly 6.023 into 10 raised to power 23 number of atoms, right? Or 6.023 into 10 raised to power 23 number of molecules, right? Number of molecules. Again, the same thing, whether you are taking it the atomic state, or you are considering molecular state. So again, if I take the example of oxygen again, example is 1 mole of O or O2, right? 1 mole of oxygen atom is equal to Avogadro number of atoms. Yes, Avogadro number of atoms. But if I am considering 1 mole of oxygen molecule, what we have to write is, let me write it first, oxygen molecule, then you have to write what? Avogadro number of molecules. So here Avogadro number of molecules. But if I ask you that, then how many number of atoms? As you can see that one molecule of O2 consists of this 2 atom, right? So number of molecules, whatsoever be the number of molecules, you have to just multiply with 2, because 2 is the atomicity of O2. So whichever whatever gas you are taking, like ozone, if you are taking ozone, then you will multiply this Avogadro number with 3. So 2 into Na number of molecules, sorry, number of atoms. Now you have converted in number of atoms, right? So this was the second definition. Now I am going to take the third definition, and the third definition is only in some special case. What exactly is that special case? That special case is the case of gas. Okay. Delete it. Fine. Right. So third definition is if I want to correlate 1 mole in case of gases, okay? So here I am writing it as in case of gases. In case of gases, 1 mole will be always equal to 22.4 liter of any gas, 22.4 liter of gas at STP, okay? At STP. Whether I am taking O2 gas, whether I am taking CO2 gas, always, right? Now here comes the scenario that if I want to correlate mole concept, I can correlate it with, again I am revising it, just I can correlate it with mass, with number of particles, and in case of gases we'll correlate it with volume. So it depends on the question that which correlation you have to choose. Sometimes you have to choose mole with the volume or mass or particles. Sometimes you have to choose number of particles with, you have to correlate actually number of particles with mass. So basically every relation is based, every numerical is based on these 3 definitions only and only. Now I am going to take a question. I hope you'll get to know about the whole concept, mole concept, from the same numerical, right? Where exactly is the question? Yeah. So this is your question, right? It was being asked in the past few years of NEET exam, I think last year 2023. So what exactly is being asked here? Just okay. So right option for the mass of CO2 produced by heating 20 gram of 20% pure limestone. Are you getting it again? 20 gram of 20% pure limestone. What exactly does it mean? It exactly means that the limestone that you have been provided, it is basically impure, and out of that whole limestone, only 20% is pure. So what you are going to take is, first of all, equation is given, right? Equation is already given. So it has been asked about the mass of CO2 produced. Can you correlate, again stoichiometry comes, can you correlate that 1 mole of CaCO3 produces 1 mole of CO2? So if you can calculate how many moles are being produced, you can calculate the mass very easily, right? So firstly we'll calculate number of moles. So weight of that limestone given, weight of limestone that is given, this is 20 gram. 20 gram of 20% pure limestone. What exactly is mean? The weight of pure limestone is 20% of a gram. 4 gram. Only 4 gram is pure limestone. Can I calculate the number of moles out of this? Yes, definitely. If I want to calculate number of moles of, this was actually for limestone, calcium carbonate, right? So number of moles for calcium carbonate will be given mass and divided by molecular mass. What exactly is given mass? That you have just calculated, that is 4 gram. What is the molecular mass of calcium carbonate? 100 gram. Calcium 40, carbon 12 and 3 into 16, right? So 100 gram. So here comes 0.04 mole. So you have calculated pure amount of calcium carbonate in terms of number of moles. Now you can easily calculate that 1 mole of calcium carbonate gives 1 mole of carbon dioxide. So 0.04 mole will give 0.04 mole of carbon dioxide, right? So I am moving on the next slide. So 1 mole of calcium carbonate gives 1 mole of CO2. 0.04 mole of calcium carbonate will definitely give obviously 0.04 mole of CO2. So you have to just apply simply unitary method, nothing else. And for mass, what you have to do is, now here comes mole concept, that you have to multiply. 1 mole is exactly, you have to calculate mass, right? 1 mole is exactly equal to atomic mass or molecular mass. Here is you have been given as CO2, which is a molecule. So 0.04 into 44. 44 is the molecular mass of CO2. So now you will calculate 1.76 gram. Simple. So the options that were given out of these, 1.76 gram is your it. Thank you so much. So that's it. We'll further discuss next topic. Bye bye. Take care.